In the cold silence of early November, the universe whispered again. A faint pulse of light, almost lost among the countless stars, appeared on a telescope screen in a quiet observatory in Crimea. It was the night between the 2nd and 3rd of November, the kind of night astronomers dream about, crisp, clear, and infinite. There, under a dome of quiet sky, the story of a new celestial wanderer began. The observer was Gennady Borisov, a man whose name already carried weight in the world of astronomy. Years earlier, his home-built telescope had revealed the first confirmed interstellar comet ever seen, a fragment from beyond our solar system. Now, 6 years later, his lenses had captured something else, something both familiar and utterly alien. On the digital frame, the unknown object appeared as a soft blur of light, a diffuse glow without a tail, brighter than the empty sky around it, yet strangely calm. Its motion, slow and deliberate, betrayed that it was not a background star. It drifted against the tapestry of fixed constellations, as if slipping silently through the folds of space. Within hours, its coordinates and initial magnitude, around 12.1, were transmitted to the global astronomical network. The signal went out like a quiet alarm in the scientific night. A new object had entered our sky. At first there was restraint, a waiting, a holding of breath. But then, as data came in from observatories in Russia, Japan, Ukraine, and the Canary Islands, the faint blur grew into something undeniable. It was real, it moved, it brightened, and yet it broke the rules that had guided cometary science for generations. No shimmering tail, no trace of ionized gas, only a dense, glowing coma. The luminous heart that should have birthed a stream of dust and ice. But it didn't. The laws of physics seemed to hesitate. They called it provisionally S2025 Borisov, a name that quickly began to echo through digital forms and late-night observation logs. Amateur astronomers aimed their modest telescopes toward Virgo, the constellation of the Maiden, where the object crept along its unusual path. In the darkness of their backyards, through the hum of cooling fans and the faint chirr of crickets, they watched what looked like a small smudge of light, brightening with every passing night. Something rare was unfolding, though no one yet knew what it meant. By the 3rd of November, the alert had reached the Central Bureau for Astronomical Telegrams, and the discovery was confirmed. The world of astronomy, professional and amateur alike, converged on the same mysterious point of light. What was it doing there, drifting between Earth and another cosmic traveler, the strange interstellar comet known as Tailless? The alignment was too close, the brightness too unnatural, the silence of their tails too deliberate. It was as if the cosmos had chosen this moment to blur the line between what we know and what we only think we understand. Night after night, reports flowed in. Observers in the northern and southern hemispheres compared notes, shared spectra, traced the object's motion pixel by pixel. Its coma grew, not in chaos, but in calm radiance. A circular, concentrated glow. Some images hinted at faint extensions, but nothing consistent, nothing that resembled a comet's classic plume. Instead, the light seemed trapped, contained, as though the dust itself refused to drift away. What kind of comet does not obey its own nature? What kind of object shines brighter yet remains shrouded in mystery? In those hours of patient wonder, a thought began to spread through the community. Could this be the beginning of something larger, a cosmic alignment, a gravitational resonance, or perhaps a new kind of encounter never witnessed before? Between Earth, the old visitor Tailless, and the newborn S2025 Borisov, something subtle was taking shape, an arrangement too delicate to ignore. The three lights, now visible together before dawn, glowed like punctuation marks written across the fabric of the sky, and beneath that silent choreography, questions multiplied. Was this an illusion of perspective? A chance alignment? A visual echo of the solar system's geometry? Or was there an unseen thread connecting them, some deep resonance of celestial mechanics, still waiting to be understood? As dawn crept over the horizon and the stars began to fade, the mystery only deepened. The stillness of space had been broken. Somewhere between mathematics and wonder, the sky had begun to speak again, and its message was only beginning to take shape. The discovery of S2025 Borisov unfolded not as a single event, but as a wave, spreading across continents, observatories, and minds, reshaping the quiet rhythms of astronomical routine. What began as a faint, almost imperceptible blur on a single monitor soon became the focus of an international campaign. Each hour brought fresh observations, and each observation deepened the mystery. The data, though abundant, resisted simple explanation. At its core, the enigma was this: two bright comets, S2025, V1 Borisov, and 3 Atlas, were simultaneously visible from Earth, both shining more intensely than expected, both eerily lacking tails. It was as though the universe itself had decided to rewrite one of its oldest visual signatures. In Crimea, the Morgo Observatory continued to track the newcomer through the early days of November. The night sky was calm, the stars sharp. Every exposure revealed a steady rise in brightness, and yet the comet's structure remained unusually stable. A luminous sphere, thick and sharply defined, refusing to stretch into a filament of dust and gas. Around the same time, on the island of La Palma, the Cherenkov facility confirmed identical results. The same diffuse glow, the same absence of tail. In Australia, at Siding Spring, observers reported the same: a circular cloud of light, dense and nearly static, with only a suggestion of elongation under long exposure. The consistency across hemispheres ruled out error. What Borisov had seen was no artifact. Something genuinely strange was drifting between our planet and the distant interstellar visitor. By November 3rd, the International Astronomical Union assigned the object its formal designation: Comet C2025V1 Borisov. The announcement spread rapidly through online scientific bulletins and data repositories. Amateurs with mid-sized telescopes began confirming it within hours. What astonished even seasoned observers was not only its brightness, but its behavior. Over just 5 days, it had increased in visual magnitude by more than 5 steps. Nearly a 100-fold rise in luminous intensity. Comets sometimes flare, driven by jets of sublimating ice erupting from their surfaces, but such rapid and sustained brightening without visible tail activity was almost unheard of. Soon, the comparisons began. The interstellar comet 3 Atlas, still traveling along its hyperbolic escape path, exhibited the same contradiction. A brilliant coma, tightly packed, almost golden in tone, but no trailing filament of dust. Both comets were caught in the same sector of sky near Virgo, where Earth's orbital plane allowed an almost perfect visual alignment. To the human eye, it looked as if the two were neighbors, drifting in tandem like twin ghosts through the dawn, but the reality was far different. Orbital models from NASA's Jet Propulsion Laboratory and the European Space Agency showed vast separations between them, tens of millions of kilometers. Their proximity, in truth, existed only in projection. The coincidence of geometry and timing had created a perfect illusion. Still, the illusion alone could not explain the parallel anomalies. When scientists from the European Southern Observatory and Japan's National Astronomical Observatory analyzed the first spectra, the data suggested low levels of volatile emission, traces of carbon compounds, faint hints of water vapor, but no strong cyanogen or hydroxyl lines that typically betray active sublimation. In other words, the comets glowed as if alive, yet breathed almost nothing. Their brightness came not from gas, but from dust. Dust that behaved in defiance of the solar wind. Astrophysicists turn to the concept of the radiation pressure parameter, VE, which quantifies how sunlight pushes on dust grains. In typical comets, V values near or above 1 indicate that fine dust is rapidly expelled, creating the long, luminous tails that arc across the sky. But the models for both Borisov and 3 Atlas pointed to V far below 1. That meant their grains were large, dense, and refractory, too heavy to be carried away by sunlight or plasma flow. Instead, they lingered near the nucleus, thickening the coma but leaving no trail. The result was a paradoxical kind of beauty, a comet that glowed not because it was shedding, but because it refused to shed. As the data accumulated, a pattern of strange calmness emerged. Normally, as comets approach perihelion, the point of closest approach to the Sun, they erupt in activity, releasing jets of vapor that cause irregular fluctuations in brightness. But both Borisov and Atlas remained steady, their light curves smooth and predictable, as though their surfaces were sealed beneath some protective crust. The stability was unnerving. It defied the expectation that comets, being fragile and chaotic, must always dance to the sun's heat. By November 6th, the global network of observatories had built a timeline of the object's evolution. Photometric measurements from Japan, Ukraine, and Russia aligned almost perfectly, confirming a visual magnitude around 12, rising to 10.9 by the 4th. The coma had expanded to more than 4 arc-minutes in diameter, yet its brightness profile followed an almost mathematical gradient, with no jets, no asymmetry. In the forums of the International Comet Quarterly, scientists speculated whether the nucleus of Borisov might be covered in unusually coarse dust, millimeter-sized grains that trapped heat and slowed sublimation. Some proposed that its surface composition might resemble carbonaceous chondrite, more asteroid than comet, suggesting a hybrid object from the boundary between icy and rocky realms. And yet, the deeper question remained: why now? And why here? The odds of 3 active comets, S2025 V1 Borisov, 3 Atlas, and S2025 K1 Atlas, aligning in the same section of sky within days, were astronomically low. Even rarer was their shared behavior, the same tailless luminosity, the same unbroken calm under solar wind pressure. Some astronomers whispered of resonance events, subtle gravitational harmonics linking their orbital planes, perhaps driven by Jupiter's distant influence. Others suggested coincidence, a fleeting trick of perspective amplified by our planet's orbit. But for many, it was the kind of coincidence that feels too elegant to dismiss. Meanwhile, solar activity was rising. A series of strong coronal mass ejections struck the inner solar system during that first week of November, igniting auroras across northern latitudes. If the comets were truly passive, their inertness should have changed under this bombardment. Yet night after night, observers reported no visible reaction. Their comas neither expanded nor dimmed. Their tails, still absent, refused to form. The silence was as puzzling as it was eloquent. It was as if these bodies were insulated from the violence of space. The planetary science divisions of NASA and ESA began issuing joint statements encouraging continued monitoring. Both agencies emphasized that the anomalies might offer rare insight into the structure of primordial cometary material, matter unaltered since the dawn of the solar system. The peculiar dust retention could reveal clues about grain cohesion, electrostatic binding, or even the influence of magnetic fields at the microscale. Instruments sensitive to polarization were deployed to measure light scattering from the coma. The results suggested that the grains were larger than expected, with high albedo values, possibly silicate-rich, possibly metal-bearing. Such composition blurred the distinction between comet and asteroid. On the morning of November 7th, orbital solutions were refined. The geometry revealed that, from Earth's point of view, the 3 comets appeared within the constellation Virgo. but in space they were separated by immense distances. Borisov's path cut below the plane of the ecliptic, approaching to about 0.55 astronomical units from Earth, while 3 Atlas glided well above the plane, bound to a hyperbolic escape orbit. K1 Atlas traced yet another trajectory through Leo, tilted steeply relative to both. Though their apparent clustering was optical, it produced a visual spectacle unseen in decades. 3 comets glowing before dawn, each with its own character, each bound to the same unseen rhythm of motion. The event mobilized not just professionals, but a worldwide community of citizen astronomers. Forums filled with real-time photometric updates, comparison images, and sketches. It became a nightly ritual. To rise before dawn, aim a telescope toward the southeast, and watch the soft spheres drift against the starfield. In those hours, scientific rigor met quiet wonder. Data tables mingled with poetry, light curves with dreams. The cosmos had once again blurred the boundary between observation and reverence, but beneath the awe lay a deepening unease. Spectroscopic data hinted at an abnormally weak production of hydroxyl radicals, which are typically a dominant emission in water-driven comets. That meant either the comets contained little volatile ice or their surfaces were somehow sealed. The idea of dormant or crusted comets was not new, but the synchronization of behavior between Borisov and Atlas suggested a shared origin, or at least a shared history. Were these fragments from a single parent body, shattered long ago? Or were they visitors from entirely different realms, coincidentally displaying the same defiance to sunlight? The data refused to choose. In Beijing, analysts at the Chinese National Space Administration reviewed footage from the Tianwen Mars orbiter. Its distant instruments had captured a low-resolution video sequence of Borisov, confirming the bright coma but revealing no structural detail. The silence from orbit only sharpened the hunger for more. Proposals flooded in for imaging time on the Hubble and James Webb telescopes. Scientists argued that even a few frames could distinguish whether the brightness came from surface scattering or active emission. Yet bureaucratic schedules moved slowly. The comets continued to drift, bright and unyielding, beyond the reach of bureaucracy's pace. Each day that passed without new images strengthened the mythology around the discovery. Some claimed the brightness fluctuations hinted at internal reflections from crystalline surfaces. Others invoked magnetic coupling or electrostatic cohesion, preventing dust escape. A small but vocal group speculated on interstellar origins, that perhaps Borisov, like its namesake of 2019, had come from beyond the heliosphere, carrying exotic matter resistant to solar radiation. But the measured orbit remained elliptical, bound to the sun, though highly inclined. It was a child of our system, not a stranger from another star. In the midst of these analyses, a subtler mystery appeared. Radio telescopes in Japan and Ukraine detected faint background noise near the coordinates of Borisov, an irregular emission just above baseline cosmic background levels. The signal was likely instrumental, yet its coincidence fueled discussion. Could the dense dust environment scatter radio waves differently, producing anomalies in passive readings? Or was it simply the byproduct of interference from Earth's own atmosphere? No conclusion was reached, and the reports were quietly archived. The story of Borisov and Atlas was no longer just about comets. It had become a meditation on uncertainty, on how, even with our instruments and algorithms, the universe continues to withhold simple answers. As the week progressed, both comets remained bright, stable, and strangely silent. Their comas shone like frost under a pale dawn, revealing everything yet explaining nothing. Scientists from Caltech's Palomar Observatory calculated that Borisov's nucleus might be rotating slowly, completing a turn every 27 hours. Such slow rotation could limit outgassing, preserving symmetry in the coma and preventing the formation of directional jets. Combined with heavy dust particles and low V, this could produce exactly what observers saw, a brilliant, tailless sphere of light. But even this model failed to explain the synchronicity between Borisov and Atlas, two bodies millions of kilometers apart, responding identically to solar conditions. As mid-November approached, attention turned to predictive modeling. Would either comet fragment as they approached perihelion? Historically, comets with sealed crusts often disintegrate abruptly once internal pressure overwhelms the surface. If that were to happen, astronomers hoped the event would reveal the true nature of their composition, perhaps even confirm or refute the presence of interstellar dust components. Yet night after night, both remained intact, unwavering, glowing softly as they climbed the dawn sky. For the public, the sight became a quiet phenomenon. Photography groups across continents captured the trio, Borisov, 3 Atlas, and K1 Atlas, each distinct, each radiant. Online galleries filled with long-exposure mosaics of the Virgo-Leo region, showing golden points where tails should have been. The images carried a strange stillness, as though the heavens themselves were holding their breath. And still, the question lingered, whispered between data lines and sleepless observers. What exactly are we seeing? Is this a rare alignment, a temporary balance of forces, or a glimpse of some deeper mechanism the solar system hides within its clockwork? The silence of their tails became its own kind of voice, one that spoke not of absence, but of restraint, of mystery, of cosmic intention. In the history of astronomy, there are moments that redefine our expectations, when a simple observation opens a rift in understanding. The discovery of S2025 V1 Borisov was one of those moments, two luminous, tailless wanderers appearing together in the sky, breaking rules that seemed immutable. As the days passed and the data multiplied, one truth remained constant. The universe had revealed not an answer, but a question vast enough to fill the night. Every celestial discovery carries within it the echo of the person who found it, and the story of S2025 V1 Borisov is inseparable from the man who first noticed its quiet shimmer in the depths of space. Gennady Borisov is not a figure of grand institutions or vast research budgets. He is a craftsman of the stars, a self-taught engineer who built his own telescopes from metal and glass in a modest workshop in Crimea. In an age when most astronomical discoveries are made by automated surveys and artificial intelligence, his work remains profoundly human. A blend of patience, intuition, and an unshakable fascination with the unknown. When his telescope first captured the faint glow of the object now bearing his name, it was not just the triumph of a single observation, but the continuation of a lifelong pursuit, the search for signs of other worlds and the boundaries of cosmic possibility. Borisov's earlier discovery in 2019, the interstellar comet that also carried his name, had already carved his place into scientific history. That object, the first known visitor from beyond our solar system, challenged astronomers to rethink the limits of celestial migration. Now, 6 years later, history has repeated itself in a subtler, more mysterious form. The new Borisov object does not race through the solar system on a hyperbolic trajectory. Instead, it drifts like a quiet thought between worlds, neither fully comet nor asteroid, reflecting sunlight in a way that seems almost deliberate. Its presence recalls the humility of observation itself, how much the cosmos can reveal when one simply listens. The technical legacy of this discovery is already profound. Astronomers studying S2025 V1 Borisov are constructing new models of cometary evolution that challenge established boundaries between active and dormant bodies. The absence of a tail, combined with sustained brightness, implies a new class of objects, hybrid comets whose surfaces are sealed by thermally processed crusts, yet whose interiors still contain frozen volatiles. Such objects might represent an intermediate evolutionary stage, the fading heartbeat of ancient comets that no longer vent gas but still scatter light through the heavy dust of their surfaces. In these dense shells, grains cling together under weak electrostatic forces, forming clusters too massive to be swept away by solar radiation. The universe, it seems, has more ways of preserving its relics than we imagined. Yet the discovery's significance extends far beyond physics. It touches on the nature of human curiosity itself. Every night, as amateur observers turn their telescopes toward Virgo, they participate in a lineage that stretches back centuries, from Tycho Brahe, charting the wanderers by candlelight, to the modern astronomer surrounded by digital screens and data streams. The technology has changed, but the gesture remains the same. The act of looking up, of asking what lies beyond the reach of light. The S2025 Borisov discovery is a reminder that even in an era dominated by automation, a single pair of eyes guided by wonder can still alter our understanding of the sky. In scientific circles, discussions now revolve around what this discovery might foretell. Some researchers speculate that Borisov's object could be part of a fragmented family, remnants of a parent body that disintegrated long ago in the outer solar system. If so, its dense coma and heavy grains could hold the chemical fingerprint of the earliest solar nebula, a sample of primordial dust preserved across billions of years. Missions are already being proposed to capture spectra from future passings of such objects, using high-sensitivity instruments aboard orbiting observatories. Others propose that Borisov's object might represent a previously unrecognized class of quasi-active bodies that bridge the evolutionary gap between comets and main belt asteroids. Should that theory prove true, it could redefine how astronomers trace the origins of volatile materials that once seeded the young Earth with water and organic molecules. As the days of observation stretch into weeks, S2025V1. Borisov continues to move quietly across the dawn sky, fading slowly as it recedes from the sun. Its path carries it upward through the ecliptic, into the northern constellations, away from human sight, but not from memory. In its wake, it leaves not only images and data, but a renewed awareness of how fragile our knowledge truly is. For every equation that explains one mystery, another emerges from the shadows. For every discovery that seems complete, the universe reveals a deeper layer of complexity, as if it delights in keeping our understanding forever incomplete. Meanwhile, attention turns again to Gennady Borisov himself. Those who know him describe a man of few words, devoted entirely to his instruments and the night sky. His workshop in Crimea remains modest, filled with lenses, wires, and quiet determination. There is no grand laboratory, no team of technicians, only the enduring partnership between one man and his hand-built telescope. It is this simplicity that gives his discoveries their resonance. They remind the world that science is not born solely in institutions, but in the quiet persistence of those who refuse to stop asking questions. Each observation he makes is a continuation of the same story that began when humans first looked up and named the stars. Across observatories from Chile to Japan, from Hawaii to Spain, the name Borisov now echoes in data archives, a symbol of precision and patience. Yet beneath that recognition lies something gentler, a sense of reverence. Every new image of his comet, every updated light curve, carries a quiet awareness that we are witnessing not merely an astronomical event, but a moment of continuity in the long dialogue between humanity and the cosmos. The silence of S2025V1 Borisov, its refusal to display a tail, becomes almost poetic, a symbol of restraint in a universe otherwise filled with violent motion. The same can be said of Tailless, its twin in anomaly. Though physically distant, the two comets share an unspoken kinship, as if reflecting one another across the void. Both remind us that the laws of nature, though constant, can still surprise. Both compel us to revisit our definitions of activity, of brightness, of what it means for a comet to be alive. For the astronomers who watched them, these twin enigmas became a meditation on the tension between predictability and wonder. The equations still worked, but the results sang in a different key. Now, as the season turns and the early mornings grow colder, the alignment of Borisov and Atlas drifts apart. Their orbits diverge, their light fades, and soon they will pass beyond the reach of most telescopes. But their story remains, written in data, in images, in the memories of those who watched the sky that week. Somewhere in the archives of the Central Bureau for Astronomical Telegrams lies the first message that announced the discovery. A few lines of coordinates, a magnitude, a note of curiosity. From that modest record has grown a narrative of global collaboration, of science moving at the speed of shared wonder. The aftermath of this discovery will ripple for years. Astrophysicists will refine their models of dust dynamics, comparing the Borisov data to observations of past anomalies like Hale-Bopp, Encke, and the interstellar 2I Borisov of 2019. Graduate students will base their theses on the light curves, measuring subtle asymmetries that might hint at nucleus rotation or outgassing jets too faint to see. Space agencies will cite the event in mission proposals, arguing for instruments capable of capturing such transient phenomena before they fade. The story of S2025 V1 Borisov will thus become part of the larger human pursuit to understand how comets live, die, and sometimes choose silence over spectacle. For those who witnessed it firsthand, though, the science is only part of the memory. They will recall the pre-dawn hours, the breath of cold air on observatory terraces, the hum of tracking motors as the comet's soft halo drifted across their screens. They will remember the moment of recognition, that they were looking at something that should not exist yet did. In that realization lies the timeless essence of discovery. Not the certainty of knowledge, but the thrill of mystery. In the end, perhaps that is what this story is truly about, the quiet persistence of the unknown. The universe is not a solved equation, but a living, breathing expanse of unanswered questions. S2025 V1 Borisov and 3 Atlas, in their tailless glow, have reminded us that the cosmos still has secrets to keep. Their light, reflected through countless telescopes, has bridged continents and generations, connecting scientists, dreamers, and those who simply step outside before dawn to look up. Someday, another observer will find another faint smudge of light and send another message into the global network. The data will flow again, the models will evolve, and the cycle will continue. But for now, as the comets fade into the cold and the observatories fall silent, we are left with a sense of awe, that in this vast and ancient universe, even the smallest glow can speak volumes. The sky, for a moment, opened a window into its own silence, and through that silence we heard the echo of creation itself.